So I can empathize with them. Example number 4. I'm not going to write it. I'll read it from the textbook, and then I'll show you how we write it down. It says, if a car is accelerating from zero, and it takes 8 seconds to go 352 feet. So let me write that down. 352 feet in 8 seconds. And since I was your guys' physics teacher, we're going to say that the initial velocity was 0, right? Because it said from 0, right? Okay. So that's the first thing. So it says it goes from that to that. And then it says, if the average velocity for the 8 seconds was, so they're assuming that the average velocity would just simply be the 352 feet per 8 seconds, which is equal to 44 feet per second, right? And that's approximately 30 miles per hour, okay? At some point during the acceleration, the speedometer must read exactly 30 meters per second, right? So it says, how would you prove that? How would you prove that using the mean value theorem? So what they're saying is, so think of it like this, all right? So here we have a position over time graph, all right? So this is our position, or no wait, that's time. So this would be time, right? And this would be position. So I'm just going to write that here, position. So how far has the car traveled at 0 seconds? 0 feet. So this is where the car starts. I'll draw that in a different color, right? Now does the car go exactly 30 miles, like when you get in the car, is it going 30 miles an hour right then and there? No. It kind of speeds up. So if I were to kind of sketch the graph, what might it look like? Yeah, it'd have one of these things where in 8 seconds, right? In 8 seconds, it should reach. It'll start off slow and it'll speed up, and it might even stop. Who knows what it does? But whatever happens in between, this right here would be 8,352, right? Where this is the time in seconds, and this is the position in feet, right? Now we have an interval AB. What's the interval AB if you were to list that?
0, 0 to 8.
Okay, I hear 2 things. What do you think it would be?
0 to 8.
0 to 8, yeah. So we would consider, so normally when we do the mean value theorem, and maybe I should write that down so you guys kind of can remember what we're trying to do. Remember we said that f prime of c should be equal to like an average rate of change, because that's really what the secant line represents. It really represents an average rate of change. It's not an instantaneous rate of change, it's an average rate of change. And so on the left-hand side, f prime of c is like an instantaneous rate of change. It's the slope of the tangent line at a point. Where this f of b minus f of a over b minus a, that's like an average rate of change. So if my interval then is the independent variable, which is time, right, because the position is dependent upon time, should be from 0 to 8, right? So we've got 0 to 8, right? So you can think of this as like being A, and then you can think of this as like being B. And you know what? If we plugged all the points in, because I have this point here, which is 0, 0, guess what I would have? This. This is this. And then if I reduce it, it comes out to about 30 miles per hour. Now what does that mean? that means that my secant line here has a slope of, if I were to convert it, 30 miles per hour. Whoops, that's not mph. Oh, I knew that would happen. Okay? So what they're saying is that somewhere in here, between A and B, there exists a C, right? This is what the mean value theorem means, where the instantaneous speed is equal to the average speed, which makes sense, right?
Yeah.
So they're not asking us to solve it, they're just asking us to prove it, or show it, or demonstrate it. I kind of did that with the graph, but if you think of the formal definition of the theorem, what do we have to prove? That the function is continuous and differentiable. Well, since they didn't tell us that the car stopped at all, and even if it did stop, the graph would look a little different, but it would still be a continuous graph, right? Because we're constantly tracking the position of the car versus the time, right? So even if the car were to completely stop, it's still a continuous function. Does that make sense? What I'm saying?
Mm-hmm.
And then the other thing is, would there be a corner or a cusp or a jump discontinuity? Could the car change? Could it teleport to a different position instantaneously? Because that would be a jump discontinuity, graphically speaking. It can't. So it qualifies. So that means that if the average speed of the car is 30, at some point in time the car was going 30. Now it could have started at 0, slowly went up to 10, and then to 20, and then up to 30, and even sped up to 40. But at whatever speeds the car did, in 8 seconds it had gone 352 feet. And so that's the practical application. Does anybody have any questions about that? Does that kind of make sense to you guys?
Yeah.
Okay. That's all they wanted us to do, is how do you take that mean value theorem and apply it to the real world? Okay. So that's it for that one.